Hey everyone, this is part 2 of the Roland JX-8P repair. So I'll link part 1 of this repair down below. So in the part 1 video I kind of went over the Roland JX-8P briefly, and then I started the repair on it. So when I got this unit it wasn't powering on at all, and it was due to the power supply actually having a bad bridge rectifier, among other things with it. The power supply itself was actually rebuilt. Besides that, I started tackling and testing, going through everything on there, and I realized that the edit slider was bad. So I replaced that potentiometer, that slide potentiometer in part 1 as well. So I cleaned all the rest of them. I've checked the functionality, all the sliders and the couple of switches in here are good now, which is fine. So power supply, I wanted to talk about this for another minute here, so I'll bring the camera in closer. So the power supply I want to talk about for a second, because I made a change since the first video. So as I repaired the first one, I replaced both of the bridge rectifiers with new 2-amp units made by Vichy to replace a stack 1.5 units in there. This rectifier here actually runs the 5-volt regulator, the 7805 for all the 5-volt circuitry, and it runs really, really hot. And that's premature failure you see in a lot of these JX8Ps. So I replaced it with a 2-amp unit, up the specs on a little bit, but it was still running really, really hot. So with that, I had made a heatsink for it, just a piece of copper on there, clamped it on, and it worked, but I don't know, I just didn't like it. It wasn't the, even though it's fine, and it would have been fine, but I just like doing things better. So what I was planning on doing is actually getting a bridge rectifier, mount it to this heatsink over here, and just run wires over to it. That way I could actually have it properly heat sinked. But instead of doing that, because I didn't have, the style rectifier I wanted, I did have a 6-amp unit that's a little bit overkill for this, but it'll work for now anyway. And what I did is I replaced the 2-amp unit with the 6-amp rectifier. I'll throw the data sheet up here so you can see the specs of it. And then I actually made a little heatsink for it too. So these bigger units, they've got actually the the heatsink mounting holes on them, so you can actually mount a heatsink to them in the proper way. And this alone made a huge difference. So updating the bridge rectifier by itself to a higher unit doesn't necessarily solve the thermal problem. This 6-amp unit I put in here without the heatsink runs just as hot as the 2-amp unit. I couldn't even keep my finger on it. It was hot enough to the touch that would burn me. So just putting the small little black heatsink on here, I screwed through the bottom. I cut this off from a larger unit. Makes all the difference in the world. It still runs warm, but I can keep my hand on there now, and it doesn't burn me. Measuring the temperature, it's down 30, 40 degrees or so. So it makes quite a bit of difference. So this is what I would recommend doing if you're going to do the repair on here with the bridge rectifiers. Put a little bit larger unit in, something you can mount a heatsink to. Either mount it back here to this heatsink, run the wires over, or find a small heatsink that you can actually mount on there, to get some thermal density to it. So continuing the repair for the JX8P in this video, I've got a few more things to do. I'm going to pull the main board down. I want to take a look at the display board in there, just to make sure everything's fine with it. Next, I'm going to pull the key bed completely out, remove every key, clean every key, just go through the key bed and make it look nice. I've got the 2 keys here I need to replace too that have that burn mark on them, unfortunately. Then there's Aftertouch. So I am unsure if I want to tackle Aftertouch in this video or not. As far as I can tell, Aftertouch is not working on this synth. I still need to really play with it and go through the settings a little bit more and make sure that I'm actually to make sure the sensor is actually good and it's not something else I'm just not properly setting on there. I don't think that's the case, but we'll have to see. The sensors on here, the Aftertouch sensor, it's basically just a strip with carbon on it that makes contact, as you press on it, basically, as a resistor, and it's known to go bad. And there's ways to recarbonize it and rejuvenate it and make it good again, so we'll have to see. I don't know if I want to go through that process in this video or not. It might be better for a video on its own, because I do have another synth that has Aftertouch problems as well that has the very similar contact, so we'll see about that. But for the rest of this, like I said, we're going to go through the JX8P, and then I'm going to talk about the main board too. We'll go through the components in the main board, kind of talk about how it works, both the digital side of it in terms of the processor, and then the actual analog side from your audio generator through all your filtering and everything on there. So it's pretty cool stuff. So the main board comes out pretty easy. You've got a handful of connectors here you need to take off. And due to all the really nice wire looming that's on there, you can't really mess them up, put them back in the incorrect locations. After those are out, a handful of screws on there, and then a couple screws in the back panel holding the jacks on too. After that, the board will just come forward and lay down. And there's 2 boards stacked here too. You got the display board with the switches in the front, then actually the main board on the back of that. So here is the display board, and actually my assumption was correct, I think. So this display I have, let me grab one. So this display is made by NEC. And it's the exact same one. So I actually have a bunch of these. The reason being is because this display is the exact same one used in the Lexicon PCM70. So the part number of this, if you're curious, is an FIP16A5R. So they are extremely hard to find, I will say that. I was lucky a couple of years ago I came across a person that had a bunch of new old stock ones, so I bought up as many as I could. And they were cheap too. I think he was only wanting 20, 25 bucks or something for them. So I got a bunch of these. I've used them on Lexicon repairs in the past, and it's good to know that I do have one now for the JX-8P as well. So again, this display works, so I'm not going to touch it. But if it ever does go bad, at least I know I have spares that I can use to replace it. So, the display board. This section here is like the high voltage supply that basically drives the actual LCD. And this little inductor right here, labeled T1, it's transformer. This is the part that's known to go bad. Why it goes bad, there's some theories out there. It's not really 100% known. I don't think it might be. I'm not sure. Yeah, either way, you can't get these anymore. But there is a company that spent the time to actually start making them again. Or it might be an individual. I can't remember what it was. You can find them on eBay. They're expensive. They're like 90 bucks or something like that. But at least you know you can get them. So if yours happens to go bad, you can replace it. So the reason I pulled this board out is because there are some capacitors on here. This section here, like I mentioned, this whole part's part of the high frequency drive that drives that vacuum fluorescent display. So I'm going to replace a couple capacitors on here, just a precaution, because I'm in here and there's no reason not to. I don't know if that runs hot or not. I don't think it does, but they are older units, 85 degrees Celsius, and it's part of the power supply section for that. So I will replace them while I'm in here. So you got two 10 microfarads at 50 volts and a single 100 microfarad at 16 volts. Now the switch in this board too, if your switches are going bad, the push button switches, they look rather unique, but these little tops on them actually unplug right off of there. And these switches you can still buy today. I've ordered them before. I know the part number. I'll link the data sheet if I can remember exactly what it was. But you can get these. They're very inexpensive. So, and you can, you put this little part back on after you replace it. But I went through mine. They're all working pretty well, so I'm not going to worry about switches in this unit. Okay, capacitors are all replaced on this board. So last step I'm going to do before I put this back together is I'm going to clean this display and then clean this window here. Just getting the residue or any dirt that might be on there off before I put it back in. There's quite a bit of dirt on there. So this alone should help brighten it up a little bit. See how nasty that was. Alright, so the main board. First of all, it's huge. The sheer size of it would be kind of cost a fortune to make. I left most of the wires hooked in here. You can still pretty much maneuver this around and work on it. Just protect your key bed. With some anti-static foam or something, just so you don't screw anything up. But it prevents you from having to unhook all those cables, which is nice. Anyway, so few things that you need to be concerned with, or I'd recommend doing here on the main board while you have this all out. First is the battery, which lives back here. This holds basically it battery backs up the RAM and the board for all your presets and settings and stuff like that. So it's a standard CR2032 cell with solder leads. I would replace it while you're in here because it's like a $3 part. Why not? If it's never been replaced, it's nearing end of life if it hasn't yet. Next, you got a couple switches. So this is the memory protect switch here, and then this one over in the corner is your output level setting. It's a low, medium, high level output for the actual audio levels that come out your main audio outputs. So I know that this switch in particular gets dirty. I'm sure this one probably does too, although it doesn't impact as much. But this one, your audio output actually goes directly through the switch, which puts puts it through some attenuation, probably these resistors or something there, and it will cause problems. So I'd recommend cleaning that switch. I'm just going to use some deoxit and get in there and clean it pretty well. So I'll cycle that a bunch. Alright, next is capacitors on this main board. So there's a lot, obviously. Now, these are all generally small signal capacitors. They're not exposed to the heat, and to the stress that you would see in capacitors as a part of your power supply, which are running, hard and hot, basically. Because of that, typically you have much longer lifespan on these caps, assuming they're properly rated, their voltage ratings for the circuitry there. But everything over in this area is really the audio section, between all your audio actual op amps and filtering here, and then you've got your chorus over in this section and some more output buffering over there. So these generally don't go bad at this point in time anyway. Even though the inside of the unit gets warm and all these caps get warm, it doesn't get them to the point where it causes premature failure. So granted, they're still old. If you have a unit that's got low audio output or other problems like that, caps may be suspect, but generally it's not seen on the JX-8P, so I wouldn't worry about it too much. Recapping this entire board usually is not necessary. If you wanted to do it, I wouldn't discourage it. I'm all about it, but I'm not going to do it here because I haven't seen it be a problem with this unit. With one exception. So this little area over here has to kind of do with the power supply. You got a couple diodes in here, in TO220 cases, and a handful of caps for the kind of regulation portion of this board. So these caps sit really close to these TO220 cases. Like this one here is basically touching it. And I hate it when I see designs like this, because typically when you're using a TO220 type package, it's over-spec to that size because it's dealing with some current and it's going to dissipate some heat and get warm. So because you have situations like this where you got capacitors really close to that device, these are the ones you'll see fail. I may go through and just replace this section right here while I'm in here. I don't know how warm these get. I didn't feel, put my finger on when it was on or measure them or anything like that. But generally this section here wouldn't be a terribly bad idea to replace. So here's my battery for DigiKey, part number P659-ND. It's just your standard, like I said, lithium cell. Accessibly packaged. So there. There's nothing to it. Take the old one out, put that one in. When you replace these batteries too, a lot of times you'll end up corrupting the actual RAM on there. If that is the case, you might have to factory reset it depending on the synth that you're working on. So we'll see about this one if it actually happens or not. So I want to take a look at the main board and talk about some of the specific architecture that makes the JX-8P work. There's a lot of interesting things going on. So first observation is the board is huge. Normally I like to zoom in a little bit more when I'm doing these mini explanation, tear downs, whatever you want to call them. But on this I want to show everything in a single shot, so I'll zoom out a little bit here even though you may not be able to read every part number and every chip. Second thing is that even though it's buried down at the bottom here, the board does say JX-8P. This board was only used in the JX-8P, wasn't used in any other synth. So the board is roughly split into two parts. So this over here on the right side of the screen, you've got your, I'll call it digital section, which is your main microprocessor and supporting hardware that actually runs the unit. It's the operating system for the JX-8P basically. And that ends about right here. This half going all the way over is the synthesis engine. So I'll talk about that briefly here, but I want to talk about the digital section here first. So this chip right here is your main microprocessor that runs the actual JX-8P. This is an HD6303. It's an 8-bit CPU, and it basically is part of the 68000 family. So this runs the JX-8P in terms of the user interface. It scans all the buttons on the front, for user input. It drives the display driver that actually updates the display. It handles MIDI communication through some other supporting hardware. It accepts the key input from the key bed via this chip down here. So this is Roland proprietary. But what it does is this chip actually handles the key bed scanning, I guess you would call it. So, the keybed works as a matrix. There's like rows and columns broken over the keybed there. And it handles both the velocity detection and calculation, along with, handling which key is pressed and then sending that information to the CPU, which is then passed on further. So, along with the CPU, you've got some other glue logic in here that isn't too exciting. The EEPROM right here is your main firmware for the unit. In this case, it's labeled JX-8P version 3.1, which is the latest version for the JX-8P as far as I know. But if you did need to update the firmware in your unit, this EEPROM right here is the one you would update. Along with the CPU, you've got some RAM over here. This is battery backed as well with that battery I replaced. So this is where all your user presets live, plus any other storage the unit may do. Main crystal for the unit down here, 16 megahertz. This is divided down many times throughout the circuitry in terms of different clocks are needed in different places. That's really everything in terms of the digital section over here that runs a unit. Now the synthesis engine from this portion over is actually pretty interesting. So there's a second processor in this unit. Intel, it's an 8051. This is basically a microcontroller that runs the actual synthesis unit itself. So there's a lot going on in terms of generating the multiple voices for this unit, and this is kind of the controller for all of it. Along with this microcontroller for that, you've got an EEPROM down here, or a ROM I should say. This actually handles the opcode for this microprocessor. So this is JX-8P version 3.0, and it handles all the communication, which I'm going to talk about here shortly, to generate, to produce the synthesis for this unit. So your actual voices in the synth are over here labeled A through F for all 6 voices. And you can see that they're kind of all identical circuitry that goes top to bottom here. And it's made up of a handful of components. There's a couple of quad analog switches in here, then there's a couple of op amps, and then finally you have the IR3R05, and that is both your VCA and your VCF. This is different than the VCA VCF that's actually used in the JX3P as well. It's one of the reasons why people think that there's a different character difference between these two synths, the JX3P and the JX8P, even though they are so roughly similar in the way that they operate. So this whole chain here for each voice is completely analog. There is no digital circuitry in here producing any of the actual waveforms that come out. But the circuitry is driven by digital waveforms that are actually produced as part of the clock generation circuit over here. So the JX8P's got 3 different waveforms. You have a square wave, you have a pulse wave, and you have a sawtooth wave. Those waves are produced out of circuitry in each voice, which I'll talk about here in a minute. But the source of that clock that drives these is from these 4 chips. These are 8253 programmable interval counters. Each one contains 3 16-bit down counters that are fully programmable by the actual microprocessor. So these actually provide the clock generation for all your voices. So remember, there's 2 DCOs per voice. You got 6 voices, so 12 total counters are needed to drive this. And with this case of each one containing 3 counters, you've got your 12 counters there. I actually want to talk about these a little bit more because they are pretty interesting chips. So the 8253 is actually a pretty old chip. It was used in the IBM PC for a timer that actually controlled various things within the actual computer itself. So this book actually talks about it here. So there's an 8253 already on the IBM PC system board. It uses all 3 timers. One's for memory refresh, to actually refresh the onboard DRAM. Tone generator, so the speaker inside the original IBM PC was actually driven by an 8253, which is kind of interesting because they used it for, I wouldn't call it synthesis, but it's generating actual tones. And then the third is the time of day interrupt. So it actually was used for some interrupts when the machine inside the machine as well. Here's an actual early IBM PC 8086, and you can actually see the 8253 sitting right there. So there's various modes that this chip can actually run in, 6 different ones actually. And you can see here I'm under mode 3. This is actually a square wave generator. So you can actually program this to provide a square wave of various frequencies, basically from DC up to, I think it was 5 or 8 megahertz. I can't remember exactly the specs on there. But this is important because you can easily divide this down and produce any square wave for nearly any frequency within within reason. So both the actual square wave and the sawtooth wave are driven by the clock, the square wave that comes off this 8253. So if for a DCO you have the square wave option selected, the 8253 is producing the square wave, which is then driving the analog circuitry to actually produce that waveform. So there's actually an op amp in each voice, 2 of them, one for each DCO, that's actually set to produce the actual square wave. So the square wave isn't actually this digital waveform, going directly out the synth. It's actually being driven by an analog op amp. So the sawtooth wave is definitely the most complex wave that's being generated, and it's doing so within each DCO itself. So the microprocessor can select one of these quad analog switches to put it in a mode where it's actually using a ramp generator. And the way that it works is that it uses one of these capacitors to basically charge, and that gives you a slow ramp up in the sawtooth wave. And then basically it resets and then drops that wave back down, and that's how you actually generate your sawtooth. And because it's being programmed via these programmable timers, it can do the same thing, basically by adjusting the frequency of that sawtooth wave for the actual output. So on a key press, a lot of things happen on the synth. So any key that's pressed, first thing that happens is the chip over here basically decodes the actual key, which key it was, and then also does the velocity calculation. That information goes then through the microprocessor, which then goes and programs one of the counters, or two of the counters I should say, for each DCO in the A253s. So those registers are programmed in here, on the fly immediately when the key is pressed. And then those square waves, that square wave or pulse wave basically comes out of these, goes to your selected voice, which produces your audio output. As you select multiple keys and stack up the voices, another one of these counters, two more of these counters for each voice keeps getting programmed. Now the A253s only have a single clock input. So if you were to have multiple voices come off of this actual chip here, you wouldn't be able to adjust the pitch or the frequency between them in terms of not the actual counter itself, but one counter compared to each other. So for things like oscillator detuning and pitch bender and other items like this where one or both of the DCOs may be off tune, from the second DCO or off tune from each other for that matter, you need to make sure that you don't have both of those square waves being derived from the same chip, and that's exactly what Roland has done here. So they actually, for each voice, they pull one of the actual timers off of two separate A253s, and that's true for every voice there. That way you're able to detune one of the DCOs without modifying the pitch of the second one. So each voice in the synth, as I mentioned, is completely analog, and that's why this is technically classified as a true analog synth, even though everything is still derived from digital circuitry. Now, the wave generation circuitry is based on a couple op amps there, one for each voice, and then that circuitry can be switched to be these analog switches, so it can actually be the ramp generation circuitry as well that produces that sawtooth waveform. So it is kind of the best of both worlds in sorts, because even though everything's derived digital, it's all coming from a quartz crystal, so it's locked down, it's going to be accurate. It's you're not going to have the drift problems and things like that you do with true analog oscillator synths versus this style, which is actually digital based in terms of the way the clock is produced. So the output of both your DCOs is then mixed, and then it goes through your IR305, your VCA and your VCF. So this provides all of your filtering in terms of low pass filtering, and then your resonance and volume control as well. Output of all the IR305s then are also mixed together, and then it goes over to this portion of the circuitry here, where you've got a couple different sections. You've got your MN3009s. Those are your bucket brigade chips that actually produce your chorus. And then finally, you've got some final driving op amps, for volume control, and then also your high pass filter is located over in this section too. And then the output then goes out your main outs, and then your headphone jack. So that's just kind of a brief summary of how the synthesis engine works within the JX-8P. There's a lot more chips in here too. There's a lot more going on. You've got some analog digital converters that are actually handling your pitch bender and your slider on the front that are replaced to convert that to digital data. There's a lot more chips just for glue logic. You've got other buffers in here. You've got decoders. You've got counters. So I just find the synthesis engine in this to be really elegant and clever. They didn't use any expensive parts. These are all commodity parts that are inexpensive too, especially for the time. There's no custom silicon or anything like that in here that they use for the actual synthesis portion. It's just a good, thought-out design that works really well. Alright, so powering it back up, I just want to make sure everything's fine since the battery replacement. Looks to be. So internal memory. Let's see, can you see that? Yeah, you can see that. So it's corrupted, as I mentioned, because the battery replacement, all memory in that RAM was lost. When I put the new battery back in there, it's just all the RAM is in a random state, and that's why you're kind of seeing, just garbage on the display there. The interesting fact about that is sometimes you can get sound out of that after this happens. So it's almost like, all that data is there. It's not necessarily valid, but when you read in one of these presets from that memory, a lot of times, that data can be valid for certain things. It sets your VCO, sets your oscillators, sets your waveform envelopes, all that type of stuff, and can actually produce sound. So it's almost like kind of a random setting. A lot of synths now you see that's got the random function where you press it and it just randomizes everything and gives you random sound. So it's kind of like that in that regard, although I'm not getting much out of it here. So actually there's one. Kind of interesting. So ultimately this doesn't matter. It's not going to affect anything. Now the JX-8P, as far as I know, doesn't actually have a reset where you can just reset the internal memory banks back to something or nothing for that matter. If you want to get presets on there, you can either take a sysx dump and import in this machine to replace this garbage with the actual internal the defaults or whatever you want to use, or just go through and just start overwriting this whole section with whatever patches that you wish to have in there. So I think I'm going to pause at this point. This video is already about 30 minutes long. I don't want to go over much more than that. but there's still quite a bit to do. So as you can see here, the key bed's been removed. I've worked a little bit on that now. I've at least pulled it out. And the next video will cover the key bed in terms of rebuilding that, replacing keys, cleaning, etc. And then there's a handful of last little details I want to go through on the synth to make sure everything's good, 100% perfect on it. So I hope this video was beneficial to you, and I hope you enjoyed it, and thank you for watching.